lecture number 6, and which is Hofmann eliminations reactions. Hofmann exhaustive, methylation, and elimination reactions. Okay. So those students who are not aware about that Hofmann elimination reaction, just I give you the brief descriptions about that elimination reactions and Hofmann eliminations. Okay. So just you see that what we have done in the eliminations reactions in the E1 and E2. Okay, so elimination reactions is so many types, correct? Now, one eliminations, which is the alpha eliminations. Second, this is the 1,2 eliminations. 1,2 eliminations. Okay, this is the beta eliminations, right? And student, there is a 1,3 also. It's a cyclic compound will form, and then the 1,4 also. So anyway, we have to study the 1,2 eliminations, beta elimination reactions. Student, beta elimination reactions, we have it two types. One is syn eliminations. Syn eliminations, which is a EI. We will study EI, students. EI part is a cope eliminations, pyrolysis of ester, pyrolysis of xanthates. These are the EI elimination reactions. So it is a part of the JEE, not in the NEET syllabus. So you can ignore the EI eliminations, especially I'm talking about the NEET students. Okay, now one is a syn eliminations, second is anti-eliminations. Anti-eliminations. Student, anti-elimination is E1, E2, and E1 CB. These are the anti-eliminations. Student, what happened? Majority of the reactions, ZG is favored. Means ZG is a major product. Either you talk about E1 or E2. Okay. So most of the reactions, ZG is a favoring. ZG is the major product. Okay. But few reactions which favor the Hofmann eliminations, Hofmann product. So what I'm talking about, you will study in Hofmann. In some cases, you will study the Hofmann as a major product, and majority is a ZG is a major product, right? Now the point is, see how you will check that whether the ZG or Hofmann is a major product. Only one way, students. Reagent give you the navigation. Reagent will give you the idea that whether it is a ZG or whether it is a elimination, the Hofmann eliminations. For example, I'm talking about CH3 all 3 CO negative K plus. Okay, this is the tert butyl oxide. So potassium tert butyl oxide or thorium oxide or tungsten trioxide. Student, these reagent will favor the Hofmann eliminations. Okay, this reagent will favor the Hofmann eliminations and E2. Especially these two reagents will favor the E2, or you can say that all favor the E2 because of yes. So that will favor the E2 eliminations. Now, students, we talk about Al2O3 and phosphorus pentaoxide. Even though conc H2SO4, if you have a 2 degree, if you have a 2 degree or 3 degree. So Al2O3 and P2O5, this reagent will favor the E2 and ZG eliminations. ZG elimination. Okay. For example, I give you that you have the CH3, CH2, and CH, Cl, CH3. Okay. So suppose you have taken that or OH. I am taking here OH. So OH is that, and here is that reagent is. Suppose I have taken the P2O5, and here is a thorium oxide. What do you think? Still P2O5 favor the ZG elimination. According to ZG, what happened? CH3, CH double bond CH and CH3. And elimination is the what? CH3, CH2, CH double bond CH2. This is the Hofmann elimination product, correct? Huh? And this is ZG product. So ultimately, you will have an idea if you know the reagents. Then you can easily check that whether it will favor the ZG or Hofmann's. Okay. But now we are discussing about a Hofmann elimination. So students, okay, now according to Hofmann, what you have done, according to Hofmann, Hofmann is that Lays substituted alkene is the major product, correct? Because complex reagent cannot attack on the beta positions of the, see, here is a alpha, it is a beta, here is also beta. So if you have a complex base, that will face very hindered to attack on the beta position. So therefore they attack on the less hindered beta positions, okay, here. So now the point is, students, obviously Hofmann is the E2 process, and second is it will favor the even CB transition. Even CB transition, when we talk about even CB transition, means that the intermediate is carbanion is formed. Okay, carbanions negative charge transition state will form. Okay, now see here, one example I give you. We have done that ammonia lysis reaction. Okay, ammonia lysis reaction, what we have done, see student, ammonia lysis is SN2 process, correct now? SN2. Why I teach you here ammonia lysis reaction? So that you can understand perfectly the Hofmann exhaustive methylation reactions. Therefore, see here, Rx we have, and suppose we have a tacanic excess, and here is the ammonia. What will happen? That will form the RH2, correct now? Okay. Again, we'll take the Rx, because Rx we have a taken excess. So what happened? That will form the R2 and H. And when we take Rx again, that will form the R3 and when we'll take that the Rx, that form the R4 plus R4 and plus X negative. It means what we have done here is quaternary ammonium salt is formed. Okay, quaternary ammonium salt is formed, correct? Now students, what do you observe anything here? What do you observe here? Student, Rx reacted till all the hydrogen is exhausted. Means reaction of Rx will be happen until and unless all hydrogen will be exhausted. Once the all hydrogen exhausted, that form the quaternary ammonium salt, and which is called, that the process is what I'm talking about, HEME process, Hofmann exhaustive methylation and eliminations. Okay, now understand this process is completely SN2 process. This is the SN2 process, correct now? So similarly, students, Hofmann exhaustive methylations is the SN2 process and elimination is E2 process. Okay, so let's understand through the example. Okay, see here, students. So we have okay, see here there is a one compound. Okay, and we have taken the CH3I. Exactly same logic we are going to apply. Same process. We are going to form here quaternary ammonium salts, because after quaternary you can use the Hofmann exhaustive eliminations. So here is a lone pair also. See, there is an CH3, and again because it is taken excess, so lone pair is also. Therefore, the CH3 again will react and form this compound. Correct? Now? Just to now you search here. This is the alpha position. It is beta positions. Beta position contains hydrogens. Now we'll take the AgOH, silver hydroxide. How you will get silver hydroxide when Ag2O dry or Ag2O reacted with in the presence of water. then it will form the AgOH. Now student, OH is the base. So this OH will attack on the hydrogens. The lone pair electron will come on this these positions. Nitrogen will take the electron because it is highly reactive, which have a high inductive effect here. So it will take the electron here. Now here is a positive charge and negative charge will form the bond. So what happen? It will form his bond and CH3 student lone pair. Again, what happened? CH3 I have taken, and since lone pair is there, so CH3 again will react, and and CH3 cations. Now again, here is the alpha position, here is the beta position. Alpha and beta contains H. So OH minus will again react, bond will, lone pair will come, that nitrogen will take up the electrons, and since the negative charge, here is positive charge will come. So what happen? That bond will form plus CH3 and CH3 will form. Okay. Now I give you 2-3 examples. Just pause the video, try to solve the questions, and then you see that. Okay. So second is that we have here is the group. Here is the nitrogens H, and student we have taken the CH3I excess. Okay. So now understand lone pair is there. So obviously first you have to prepare the quaternary ammonium salt. So you will prepare it. Here is CH3 and the CH3, here is the methyl group. The student is plus charge. Now it is alpha, here is a beta, and here is a beta. Okay, correct. So students see that what will happen, that the beta positions, obviously OH will attack here. Correct. It is the also alpha, it is the beta. Okay. So what happened? Once the OH, for example, here, once the OH minus attack on these positions, sorry, it is alpha. Sorry. So OH minus will attack on these hydrogens. Okay. And exactly what happened? Lone pair will come here. Negative charge will be there. And that group will shift there. Positive charge will come here. And here is the, okay, so, and here is the CH3 nitrogen, CH3 will be there. One pair is here again, so that can again react with the CH3I. So what happened? Again here CH3 lone pair is there. Oh, sorry, positive charge will be there. Now what happened? There's beta positions. OH minus can attack on these positions. Correct now? So either this is the alpha positions, it is a beta, or it is a beta. So what happened? So OH minus can attack here because here is a CH2 and H is there. So OH minus attack here. What happened? Negative charge will come here. That bond will take up here and positive charge will be there. So what happened? Here is double bond CH2. Okay. And that the CH3 and CH3 will form. Correct. Okay. Now the point is next is that next questions. Just you try to solve a student. Already came in that JEE exam. I give you cyclic compound we have, and methyl, and here is a ethyl, and here is a butyl. Okay. So first you think OH minus we have taken, and heat, what will happen? Students, see, we elaborate this compound ethyl. What we'll write? See, we can write here. This is the compound methyl and methyl CH2 CH3 butyl. Okay. So now OH minus we have it taken. So OH minus will, this is alpha, here is a beta. So OH minus will attack here and remove the water. So what happened? The CH2, H is there. So H will remove means here negative charge will come. Once the chain will contains negative charge, here positive charge is there. So that will take up the electron. So CH2 contains positive charge, and in that case, it will form the CH2 double bond, CH2 plus, and here is methyl and methyl, and here is a butyl. Okay, that will form. Right, students. Now, one more questions I give you. Here is that compounds. So here is the CH2 and plus CH3, and here is the hydrogens. OH minus we have taken the base that will attack here because it is alpha, it is a beta. And once the hydrogen will removes from here, negative charge will come as usual. Since negative charge will come, so nitrogen will take up the electrons, and what will happen? Double bonds, CH2 will form plus CH3 and CH3, CH3. Correct? So I hope you understood all these examples. Now, students, I wrap up these points with this few things here. Hofmann exhaustive, methylation, and elimination. Hofmann exhaustive first favored SN2, then favored the E2. First. Second, E1CB transitions state, it follow the transition state E1CB. Third order is second order reactions. Fourth, it should be beta acidic hydrogen. Okay, there should be beta acidic hydrogens. Okay, so that's the Hofmann exhaustive methylation and eliminations process. Once you understood the student perfectly, please share the video, like, and subscribe. Okay, thank you so much.